For over a century, urban water management has relied on a simple, linear process. We pump pristine, highly treated water into our modern cities, use it once, and then flush it away. We spend massive amounts of energy treating water to safe drinking standards, only to turn around and use that exact same potable water to cool industrial buildings and flush our toilets. This flowchart shows the physical limits of that linear model. As intense droughts reduce supply and booming population densities drive up demand, mixing all our waste streams into a single, overwhelmed exit pipe causes the entire system to break down. The engineering solution is OneWater. Instead of treating all water equally, it matches the right resource to the right use. Treating every drop of wastewater as a single, useless stream of trash is a luxury we can no longer afford. Cities are now being forced to redesign the loop. Instead of relying entirely on municipal reservoirs, modern buildings are tapping into a new supply located right in their own basements. In Sydney, Australia, the Bligh Street commercial high-rise captures and treats blackwater, raw sewage, directly on the premises. Through an arrangement called sewer mining, the building's filtration plant actually draws additional blackwater from the city grid. It recycles enough volume to meet 100% of the skyscraper's non-potable demand, completely eliminating the need to use fresh water for cooling towers or toilets. A similar strategy operates in drought-prone Austin, Texas, at the city's Permitting and Development Center. Tucked beneath an outdoor pedestrian walkway, a localized membrane bioreactor treats 5,000 gallons of blackwater every day. The infrastructure blends seamlessly into the public space, with landscaping plants growing directly out of the active treatment reactor. Piping highly treated drinking water into a toilet bowl is an engineering error. These centralized systems correct that error by capturing and reusing water exactly where it is generated. If mixing drinking water with sewage is inefficient, the next logical step is to stop mixing different types of waste together entirely. In the Oceanhamnen district of Helsingborg, Sweden, planners built a neighborhood using a system called tre rör ut, or 3 pipes out. This diagram shows the infrastructure required to make it happen. Instead of a single drain, apartments are plumbed with 3 separate lines, one for vacuum toilets, one for bath and dishwater, and a third specifically for food waste. Because the toilet and food waste lines aren't diluted by thousands of gallons of shower water, this highly concentrated material skips the standard sewer. It is routed directly to a specialized development lab. Inside, engineers extract the dense organic matter to produce biogas for energy, and they recover pure nitrogen and phosphorus to create agricultural fertilizer. By keeping the streams separated at the source, urban waste transforms from a costly disposal liability into a profitable energy and agricultural asset. But what happens when a city has absolutely zero natural fresh water left to spare? In the late 1960s, intense climate pressure forced Windhoek, the capital of Namibia, to find a way to survive with heavily limited natural resources. They built the Goriangab reclamation plant to execute direct potable reuse. They take treated municipal sewage and send it right back to the drinking tap. This flowchart details the intense purification required to ensure safety. The water passes through multiple distinct barriers. It is bombarded with ozone oxidation, pushed through activated carbon to absorb dissolved organics, and polished clean by ultrafiltration membranes. Operating continuously, this single facility safely transforms 21 million liters of raw municipal sewage into drinking water every day. The era of linear water management, pumping pristine water into a city just to flush it away, is officially obsolete. Across the globe, traditional wastewater treatment plants are being actively redesigned as resource recovery facilities. The engineering required to build completely self-sustaining, closed-loop urban ecosystems is already here, proven by decades of operational data from Australia to Sweden to Namibia. The final, most stubborn barrier to this future isn't technical, it's public perception and the psychological hesitation associated with reusing sewage. Fresh water we desperately need has been flowing right beneath our feet the entire time.